Yeah, here in this video, we will look at the demonstration for reversing a linked list. We have seen different versions of functions for reversing a linked list. So I will show you all those methods. So the first method was using array. So let us write down a function for reversing a linked list using array. So I'm using the same main function having some set of elements and the linked list is already created. So let us write the function for reversing a linked list. So here above the main function, I will write a function reverse1, which will take a pointer to a first node and call it as p. Then for reversing, we will store the elements in an array. So for storing an elements in an array, we should create an array. And we don't know how many elements we need. So we will find the length of a linked list and we will create an array of that size. So for that, I will take a pointer so that we can create dynamically. So I will take a pointer a. Then next, here I will create an array of size equal to the length of a linked list. So a assign integer type pointer and dynamic memory allocation malloc, then size of integer type because the data is integer type multiplied by length of a linked list. So for length of a linked list, we already have a function count. We will use that function and pass pointer p. Count is already available here. I'm using the same project. So count will count the number of nodes in a linked list. That is nothing but length of a linked list, this function. So coming back to reverse function. So array is created. So now for reversing, I have to scan through the linked list 2 times. One for copying the elements from linked list to array, second time from array to linked list. So for traversing, I will take one more pointer that will help me to traverse a linked list, that is q. I will use pointer q for traversing instead of p because p is already pointing on first node. Then also I may need a index, that is I, and I is initialized to 0. Now here I will scan through a linked list, that is while q, as I said, I am using q instead of p, q is not equal to null. And every time in an array of I, copy an element from queue's data, yes, then queue should move on to next node. So this will copy, and also I++. I should be incremented. Then once it has reached the end of a linked list, all the elements are copied in an array, then queue should again start from first pointer, that is p. So p is first here, and I minus minus, I should go back to the last element. Then again run a loop while q is not equal to null. Again scan through a linked list, and while scanning, we will copy the elements from array to linked list. So queue's data is assigned with a of I, and then q should move to next node and also I minus minus. That's all. So already I have explained you the whole procedure. So the code I have written and for demonstration. Now inside the main function, I will call a function that is reverse1. Reverse1 upon first. Now after reversing, it should display a linked list, so the linked list must be reversed. Let us run the program. Yes, linked list is reversed. So the elements are 50, 40, 30, 20 and 10. Originally linked list was 10, 20, 30, 40, 50. So it's working perfectly. So see on the whiteboard I have used a pointer p for scanning through the linked list. Here I have used p, it is not q. But here p is coming as a pointer to a first node, so I am using q. So q starts from p and q will be scanning through a linked list first time, and again q starts from p and q will be scanning through a linked list for second time. So don't get confused with the variables, we can use any variable name. Now I will write down second method which I have shown you for reversing a linked list. So for that I will call a function as reverse2. Reverse2, it takes a pointer to a first node and let us call that pointer name as p. P is a pointer to a first node. And in this procedure we require 3 pointers. P is already there. Q we require, that should be initially null. And also we require R, that is also null. Then P I will be using it. So P is pointing upon first node. So I have 3 pointers we will use. And I will directly write on the code how it works. Already I have explained you. While p is not equal to null, until p reaches null, then first of all r should come upon q and q should come upon p and p should move to next node. Then after that q should point on q's next should point on r. This is how we proceed. Then once we come out of the while loop, first pointer should point on node q. That's all. Function is finished. Now inside main function, instead of calling reverse1, I will call reverse2 and run it. and see whether it works. Yes, it is working. 50, 40, 30, 20 and 10. It's perfect. So we have seen two functions. Now the last function is recursive function for reversing a linked list. So I will write down reverse 3 for recursive function. So it should take two pointers, struct node pointer first of all q, and the next pointer is current pointer, that is p. Then if p, that is p, is not equal to null, it will be calling itself reverse 3 by passing here p and next is p is next. Yes, two pointers it will be passing, and while returning it will make p is next as q. And if p is null, then it should make first as q. That's all. Just 3-4 lines of code, and inside the main function, instead of reverse 2, now I will call reverse 3. Let us see. Oops, I should pass two parameters. So the first parameter is null and the second parameter is first. So it's taking two parameters. Yes, linked list is reverse. 50, 40, 30, 20, 10. I'll try with different values. I will change the values and make them as 50, 40, 10, 30, 20. So I should get 20, 30, 10, 40 and 50, 20, 30, 10, 40 and 50. Yes, it's perfect. So that's all. We have seen three different versions of reversing a linked list. One is using an array and the second one is using three pointers and the third one is recursive function. So you can practice these functions.